Behold, the toilet. The amazing, the ingenious, the glorious toilet. Push that lever and everything inside gets swept away. You never have to think about it, where it goes. It's gone, like magic. But hold on, it's not magic. What you flush down the toilet or put down the drain doesn't magically disappear. If you're in an urban area, everything you flush likely flows through underground pipes, down the street and around a few corners to a wastewater treatment facility, where the water gets filtered and treated before being released back into the environment. That's how we protect our precious water resources. So really, it's not magic, it's science. And that's where we come in. We're LOT, the Lot Clean Water Alliance. We clean the wastewater from the urban areas of Lacey, Olympia, Tumwater, and Thurston County, known as LOTT, LOT for short. Every day, we take care of the water that is flushed and drained in thousands of homes and hundreds of businesses. That's a lot of gunk, but we got this. The used, dirty water comes here, to the southernmost end of Puget Sound, via massive underground pipes, gets cleaned in a multi-step process, and then gets released into Puget Sound. Let's go with the flow and take a look at how we clean the water so that it can be safely returned to the environment. The cleaning process begins right here. Underneath this cover, you'll find a large 5-foot diameter influent pipe. Influent means incoming. An average of 12 million gallons of wastewater flow through this influent pipe every day. Here's a sample of the water that's arriving through the influent pipe. The plant's operators routinely sample the water at different stages in the treatment process. Then, water quality tests are performed in the lab. Sampling gives us a snapshot of what's in the water as it comes into the plant before we've done any treatment. Take a look at the water. What did you expect untreated wastewater to look like? People usually say it isn't as dirty as they thought it would be. They expect to see, well, poop, and it's in there. But there's also a lot of water in wastewater, from showers, sinks, washing machines, dishwashers, toilets, and from businesses like restaurants and office buildings, and more. The wastewater that arrives at the plant is actually about 99% water and just 1% waste. It is our job to get that 1% of waste out of the water. That is a complex process requiring many steps. Step 1, we take out the trash. The first stop on our tour is Headworks.
We are now in our Headworks building. This is the front of the plant and the first step for the wastewater. We're going to push it past this escalator screen and screen out any large pieces of trash. Anything larger than a pencil eraser is going to get caught on this screen and sent to the landfill. So looking at this grate, you're seeing stuff like wipes, you're seeing food stuff, you're seeing other trash that could have gotten flushed down the drain or sent down in the collection system through the storm water.
None of this trash belongs in the toilet or drain. Cotton swabs, floss, feminine hygiene products, gum, the occasional toy car, really? And the worst, wipes. Even wipes that claim to be flushable are not. They're often woven from plastics, and because they don't break down like toilet paper, they can really gum up the works. That's why we say wipes clog pipes, yours and ours. The toilet is meant for the 3 Ps: pee, poop, and toilet paper.
The only thing that should go in your toilet is stuff that comes out of you and toilet paper, and that's it, nothing else.
So the second part of our process here in Headworks is our grit channels. So after we screen that large trash out, we send the wastewater here, we add extra air to it so that we're changing the density of it, and anything heavier is going to drop to the bottom.
Things like coffee grounds, eggshell bits, and dirt. From there, they're pumped out, collected, and taken to the landfill as well. That is step number 1, taking out the trash and the grit. Here's a question. How do you think it smells inside Headworks?
It's like an outhouse, but diluted.
Old, musty, rotten, like dirty socks.
The smell in Headworks, actually over time you sort of lose the sensitivity to it, but generally it's going to smell pretty poopy.
Yeah, Poopy is right. This is one of the best places in the plant to experience the smell.
So this is one of our odor scrubbers. It's our job not only to clean up the dirty water, but to clean up the stinky smells that come with it. So we pipe air from buildings like Headworks to an odor scrubber like this one. It's really important that we don't let those smells out into the neighborhood in downtown Olympia.
Now, in order to move the water from step 1 of the treatment process to step 2, we use massive pumps. Each of these behemoths can move 4 bathtubs of water per second, or 12,500 gallons per minute. To do that uses a lot of electricity. Our annual power bill has been over $1 million per year. That's one of the reasons treating wastewater is expensive, and why energy conservation measures are included in planned plant upgrades. Under the floor in this giant room is step 2 of the treatment process, known as the primary clarifiers, which are made up of 4 huge channels.
This is where we're going to let the water settle down so we can skim out the top and bottom layers. On the top, we're going to have fats, oils, and greases floating on the water, something we call fog or scum. And then on the bottom, what's going to sink? The poop.
Lot deals with about 25,000 pounds of poop daily, though we call it sludge at this point. Inside the primary clarifiers, long panels skim the top and the bottom of the basins to remove the fog and the sludge. Even though we end up removing the fats, oils, and grease, it's best if you don't put them down the drain to begin with, because even a little bit at a time can build up in your household pipes or sewer lines and cause blockages and sewer backups that are a stinky, expensive mess to clean up. Instead, use an empty can or jar to collect fats, oils, and grease. Let it solidify and then throw it out in the trash. Notice the color of the water here is still pretty murky. At this point, we've gotten about 50% of the poop out of the water, but we still have work to do. Time for step 3. The next step in Lot's wastewater treatment is the biological process, also called advanced secondary treatment.
So once the wastewater has left the primary treatment, it goes on to secondary treatment. And secondary treatment is all biological. At that point, all the waste that's left in that water is dissolved, and we don't have machines here that can remove that. We use the bacteria, the microorganisms.
Microbes. 60,000 to 70,000 pounds of microscopic bacteria that work at the plant around the clock to help clean the water.
So they will start to remove those carbon compounds and the nitrogen compounds that would cause a problem if we were to put them out into Budd Inlet.
The biological nutrient removal basin is a huge tank, mostly underground, where we let microbes mix with the water. First, some microbes work in an anoxic environment, meaning without oxygen. Then, others process the waste in an aerobic environment, with oxygen. In these basins, we mimic nature by using bacteria to break down the waste and gobble up the nutrients, like a game of Pac-Man.
Really, the microorganisms here are the star of the show, and everything is about keeping them happy so that they can work the best way we can.
The main thing is making sure that they have enough oxygen but not too much, enough food but not too much.
Sometimes we operators think of ourselves as micro-branchers or bacteria farmers. We're just trying to do everything we can to give them the right conditions so that they can do the best job they can do.
It is especially critical that we remove the nutrients from the water, especially nitrogen, which comes from human waste, food, and some soaps and detergents. If excess nutrients are released into Puget Sound, it can cause algae blooms. Then, when the algae die and decompose, the oxygen becomes depleted in the water, which can cause other aquatic plants and animals to die. That's why this biological treatment step is so important. So, let's review. We've taken out the trash and the grit. We removed sludge and fats, oil, and grease. Then, the bacteria do their thing to remove much of the nitrogen. Now, the wastewater enters this channel.
Okay, here in this channel, we have water coming out of our nutrient removal basins. It's very brown and we're pretty far along in the process. So why is it this color? Well, it's full of our helpful bacteria. So it's all mixed up in here in brown, and the next step for us will be to get those bacteria out of the water so we can send the water to the next treatment step.
Time for step 4. In these secondary clarifiers, we let the water be still again. Here, the bacteria clump together and sink, helping pull other suspended particles out of the water. These bacteria are collected, and some are sent back to the treatment process to be reused. Now, notice the color of this water leaving the secondary clarifier, and compare it to the water at the start of the treatment process. This water is much cleaner and clearer. However, there's one more important final step: disinfecting the water before we release it to Puget Sound. Step 5. LOT uses ultraviolet UV light for disinfection. The ultraviolet light deactivates any bacteria or pathogens left in the water. UV disinfection is highly effective and avoids the need to add chemicals, though it is an energy-intensive process.
This is our final effluent channel, so after we disinfect with our ultraviolet light, the water comes here before we pump it out to Puget Sound. So at this point, we've done all of our treatment steps, and this is our clean water that's ready to be sent back to the environment.
What you sent us when you flushed the toilet or drained the sink arrived here looking like this. And now leaves like this. Remarkable. I mean, it does seem like magic, but really, it's science. A lot of science, in fact. This water has been treated to advanced secondary standards, the highest level of treatment currently provided at any wastewater treatment plant along Puget Sound. But we're not quite done. While treating wastewater is the primary purpose of the treatment plant, we also conduct resource recovery. At the Budd Inlet Treatment Plant, we recover 3 different resources. The first is reclaimed water. About 10% of the wastewater we manage gets additional treatment to become Class A reclaimed water.
So the way we produce Class A reclaimed water here at LOT Alliance is that we pump a small portion of what our final effluent is through the giant sand filters that we're standing above right now.
To produce up to 1.5 million gallons of reclaimed water per day.
Ready to be used for anything but drinking. It's going to be sent out to our city parks. We use it for landscaping. Anywhere where we can save drinking water and use reclaimed water is great for us and the community.
Reclaimed water travels through a separate piping system, color-coded purple. So if you're in a local park and you see a purple hydrant or sprinkler head, that water is reclaimed. And every gallon of reclaimed water used saves a gallon of precious drinking water for far more important purposes, like drinking. Another renewable resource is biosolids. Remember the sludge and fog that got removed in the primary and secondary clarifiers? These solids are sent to our solids handling system.
This is our digester building. This is where we send all the solids that we've separated out of the wastewater. So that's our fat, soils, and greases and our poop. We put it in these digesters to make Class B biosolids.
While we want to keep nutrients out of water, the nutrients in biosolids can be quite useful on land. So the biosolids are trucked to eastern Washington and used as a soil amendment. That's not all that comes out of the solids handling process. During the digestion process, methane gas is produced, which we capture for energy. We use it to generate electricity, which, as you know, the plant uses a lot of. We save about $150,000 a year using what we call poop power. We also capture heat from that process, which we use to heat some of our buildings and the neighboring Hands-On Children's Museum. Wastewater treatment plants are designed to remove nutrients, bacteria, and pathogens. They were not designed to remove all the chemicals from the many products people use every day, including medicines and household and personal care products. While wastewater treatment removes some of these residual chemicals, it cannot remove them all. You can help keep these chemicals and other pollutants out of our water by being careful about the products you use and disposing of medicines and products properly. The toilet. It does seem magical. Put something in it, press the lever, and it disappears. But now we know, it's not magic, it's science. At the Budd Inlet Treatment Plant, science and technology are used to clean water. This takes a lot of hard work by skilled technical experts and billions of microbes, and it takes a lot of complex equipment and energy. And your efforts in being careful with what you flush help too. But it's worth it to ensure that all the wastewater from our homes and businesses does not harm Puget Sound or our precious water resources.
Bum 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 bum.